Okay, so lesson 2.8. Those proportions we learned how to use yesterday. We're using them again today. Except today we are looking at similar figures and using those. So when we talk about similar figures, they are figures that have the same shape, but not necessarily the same size. As you look at the pictures, you see 3 different examples there, right?
Yeah.
2 sets of triangles, a set of trapezoids. It looks like the same thing. It just looked to me, I think you put it on the copy machine and you either hit the reducer or enlarge, right? You either got bigger or got smaller.
But they're all the same, but different letters and different numbers.
Okay. Now, similar figures, they have corresponding sides and corresponding angles. So like as we look here on these, there's sides that match up and there's angles that match up based on the fact that one is just a bigger version of the other shape. When we talk about corresponding angles, the angles are the same. So the corresponding angles are equal. The corresponding sides are proportional. Obviously, these sides are not the same length, but they're proportional. So they have like the same ratio. So maybe the sides in one triangle are twice the length of the other sides, or whatever the case might be. Okay, so a couple different things we're going to do. I just created the homework the other night, and I don't remember exactly what all you have to do in the homework, but cough it up, get it out.
He's dying.
Okay.
Oh, I sucked in flush.
Okay, right here, we have the statement. Triangle ABC, and then that little mark means similar to that triangle ABC is similar to triangle DEF, and identifying corresponding sides and angles. So, for instance, if I mention angle A in the big triangle corresponds with angle what in the small triangle?
D.
Agree? Angle A and angle D correspond. Now, because they are angles, notice they are going to be equal. And so I'm actually going to use the congruent mark. And the angle A and angle D are congruent. It's an equal sign with a little squiggle over it.
Okay, I was about to say, well, I don't know how to draw that.
Equal sign with a squiggle over it?
Yes.
That's okay.
I don't know what else to call it other than a squiggle, but
It's called a line.
I wonder if they have an actual term for it.
actually I want it. I don't know. Okay, so now I got you started on one pair. I said angle A is, and you guys, David provided angle D. Okay, someone else.
B and E.
D and B and C and
Okay, B and E. So angle B is congruent to angle E, and angle C is congruent to angle F. So you're seeing how we can see those similar pieces, right?
Yeah.
So those angles are equivalent. Now, we're gonna talk about the sides. So I'm gonna start with side AB. What is side AB similar to or proportional to?
D.
You guys agree with Rylan?
Yeah.
Side AB is similar or proportional to D, and I'm going to write this one differently. I'm going to make it a ratio. I'm going to say, okay, AB is proportional to DE, just as
B, C, D, F.
BC is proportional to BF. Now, BC is proportional to EF. Notice I'm keeping the pieces in the same location in that the bigger triangle pieces are on top, the smaller triangle pieces are on top, or on bottom, excuse me. Just trying to pair them up. Now, not Rylan, not David. Someone else give me the third pair.
1, 2, 3. It's so easy to write.
David. What's the other pair of similar sides?
Quiet.
Go ahead, Jason.
AC and DF.
What'd you say?
AC and DF.
Yep, I agree. AC is proportional to DF. Yes?
Yeah.
AC, DF. All I'm just trying to get you guys to do is to recognize the similar pieces. That's all I'm trying to get you to do right now. Because if you can recognize the similar pieces, when we go to try and find the missing pieces next, it'll be a little bit easier to do.
Oh, we have to find the middle.
Well, yeah,
Yeah, that's
we gotta find the missing pieces
that's
next.
gonna be a challenge.
Okay, so look at our next set of triangles. Find the missing length in each pair of similar figures. So first of all, what is it I'm trying to find here?
What?
I'm trying to find
X and A.
just x.
Oh,
You just have one side to find. So we're trying to find x. Now, you'll notice they give us a side length of 10 here. They don't give me this bottom one. Over here, we have side lengths of 3, 4, and 5.
yeah,
We want to use
6 and 8.
our similar pieces. So here's what I'm going to ask you, because we're trying to set up a proportion. X from this big triangle. Okay? What is X similar to in the other triangle?
4. One with DE, but 4.
But 4 is what I want to hear. Are you guys okay with that?
Yeah.
X goes with, just like earlier, up above, we said A, B, and DE. Except I'm going to use the lengths. So this has a length of X. This has a length of 4. So I'm going to say X over 4. Now, in order to finish this, we need to have another set of sides that pair up.
Okay, so B and 5. No, please. Yeah, B and 10. No, B and 10.
Give me a number.
10.
10 and what's 10 go with?
D. 5.
5. Because 10 is the length of this slanted side, and 5 is the length of that slanted side. Now, okay, originally when I set this up, I said X over 4. X from the big over 4 from the small. So when I use 10 and 5, I'm going to say 10 from the big over 5 from the small.
You can cross multiply that. I'm just saying. Maybe 5x.
Now, hold on. This is not the only setup we can do. We are getting ready to do cross products. If you did a different setup, as long as your cross products match mine, then it's all good. Okay, because this is the whole point of what we did yesterday. We were solving yesterday, so we know what to do from here. Today it's just how do I set this up. So what are my cross products?
So 5 and X and 4 and 10. Which?
Are you guys with him?
Yeah.
5 times x, right?
Yep.
5x.
Diagonals from yesterday. So 5 times x
5,
is going to be equal to
4, 10.
4 times 10. We're doing those cross products. 5 times x is 5x. 4 times 10 is
40.
40.
5.
Yep. Yeah.
Which is 8. You know,
If 5 times x is equals 40, divide by 5,
X equals 8.
and x is 8.
At the beginning, I already kind of knew what it was.
So why didn't you say the
I
answer?
just, because that one's 2 times bigger, so I just did 4 times 2.
Okay,
because
and I agree.
with the 5, it's and the
Okay.
other one.
Based on the fact that 10 is 2 times the length of 2 times 5, I agree. You could know from the beginning it was going to be 8. Now, here's my thing, though. I want to have this method because the number's always going to be nice and neat to us.
Yeah.
Not
The
always.
next one.
Okay? Yeah, the next set of numbers are not quite so nice and neat, are they? So that's why we want to have a way to set this up. Okay, we got a couple of trapezoids here.
They're no different. figure this out to 18 and x.
My goal is to find x.
Well, x is 7, I should say. And then 8.
Okay, hold on. Okay. So I'm trying to find x. X from the big trapezoid pairs with what?
7.
7 from the smaller trapezoid. They are both the left angled side, right?
And then 18 and 2.
Now, the other pair of sides I'm given are 18 and 10. Do I want to do 18 over 10 or 10 over 18?
10 over 18.
Why?
Because that's just how it is.
Okay. What did I do first over here? We had x over 7. X came from the big trapezoid here. So when I do my second fraction, we need to be consistent. If this is x over 7 here, then you need to go back to the big and do,
Small.
no, 18 over 10.
Oh.
Okay, in other words, you have to be consistent. X came from the big one over 7 from the small one. So then if you're going to go big over small, then over here on 18 and 10, you need to go big over small.
Wait, we do that.
How do we solve a proportion?
10 over x and 7 over 18. So it'd be 10 times x and then 17 times 18.
Okay. Cross products, right? We talked about cross products yesterday. 10 times x is one cross product, and
7 times 18.
7 times 18 is our other cross product.
And then it's going to be 10x
Equals 1.6.
7 times 18, which gives you
Is 126?
126.
Am I done?
Nope, we have to divide by 10.
Okay, if it's 10 times x, divide by 10.
And then it's, you have to reduce. You can't do
No,
nothing.
just what's 126 divided by 10?
126 divided by 10.
12.6.
Yeah, it's 12.6.
Okay. And it came out decimal, and that's okay. Because remember, when we started on this one, and Rylan looked at it, he was like, this isn't, he didn't know the answer just by looking at it and being like, oh, it's just times 2. This one didn't have quite the nice, neat relationship, which is why we want our proportions to be able to figure it out. Okay? Robbie?
Is there a water fountain like right there?
Down by Mrs. Rogers' room.
Can I go get a drink? I'm like 9.
Yeah, I'd prefer you not to die in my classroom or in the hallway,
I'll try not to.
Okay. What kind of artist are you?
Huh?
I said, what kind of artist are you?
I'm not no artist. Like, I'll get an F in art.
Okay, well, because my suggestion on this next one is that we draw a picture. Because there's no picture provided. Now, I am definitely not an artist. So if you're sitting there thinking, oh, no, I'm not. No, you don't have to be an artist. Okay, I'm not going to do anything fancy here. Now, it's words. I know. For several of you, that means skip it. But we're not going to skip it. A man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet. And the shadow of the flagpole is 17.5 feet. How tall is the flagpole? Okay. What'd you do? Just give me a random guess?
Yeah.
Okay. Not a random guess, though. Let's actually, so here's my, okay, a man. Here we go, guys. There's my man.
How do you draw a shadow?
Hold on. A man is standing next to a
Like,
flagpole. There's my flagpole. Like these fancy pictures?
Yes, they're very detailed.
Okay.
That is very detailed.
Now,
That's but
the shadow
that guy has
is
to be a little bit
The shadow of the man is 3.5 feet. Well, where is your shadow?
Down on the ground.
On the ground, yes?
Yep.
So this shadow of the man is going to be 3.5 feet. Then it says the shadow of the flagpole. Where's the shadow of the flagpole? On the ground. And that is 17.5 feet. Oh, and I forgot to say, the man is how tall?
6 foot.
6 foot. Man is 6 foot tall. Do you see the shape we're creating here?
Yeah.
Basically, what we're thinking here is these are two similar triangles.
That looks like a Dorito.
Okay. Similar triangles. Our question, how tall is the flagpole?
That was 17 feet.
Okay. Now the shadow is 17.5 feet.
Well,
So it's like half of that.
not even half.
Yeah.
Well, and this is where it's not an exact relation, is it? So we're going to set up a proportion, like we did on the others. Guys, this is just like the last two problems we did.
Not really.
Yeah.
Yes, it is. It is
You got
just,
fight with the math.
look, a triangle. We know the left and the bottom. A triangle. I'm trying to find the left, and I know the bottom. If you look up here, a triangle. Try and find the left, we know the right. We know the left and right. Trapezoid, left and bottom, left and bottom. It's exactly like the last two problems. We just had to draw the picture to get started. Okay. Start me up. What do you want to pair X with?
6.
Based on what I've been teaching, I'm going to say X goes with
6.
Oh,
6.
yeah, okay, I was thinking.
So X from the big triangle pairs up with 6 from the small triangle.
If you call that a Dorito, it looks like
Now.
a Dorito.
Focus, please. X from the big triangle pairs up with 6 from the small triangle. How do I set up my other part of this proportion? X over 6.
3.5. 17.5 feet. So 17.5 feet go on the top, and then the 3.5 feet go on the
Okay. So since X is on top here, 6 is on bottom, then that means I'm going to put 17.5 on top and 3.5 on bottom. You see that one way or another?
Yeah, but you're not doing it. Just you have to divide.
Now, can you solve this?
Nope.
Yeah.
Try it. You try it. You have calculators in front of you. Otherwise, I'd feel bad because there's decimals, but I don't feel bad because you have a calculator.
17.5
Try it on your own.
divided by.
Try this problem, Jason. Everything's written up there. See if we come up with an answer.
Okay, yes, we can actually. I know the answer. It's 5. I got an answer for that. It's 5.
Okay, Dave.
Set up your proportion.
X equals 30.
I don't want answers.
What?
I don't want answers. I want people trying it. Unfortunately, I've got most people with nothing written down.
So in that, you
Okay, hold on. I don't want answers. Got it?
Yeah, I have stuff written down though.
I still don't want answers.
Okay.
Okay? I've got most people just waiting for me to proceed. Guys, write out the next step. We did this yesterday. We did this on the 3 problems prior. I need you guys engaged with me. I can't have 2 people doing this and the rest just sitting there quiet. my cross products, my diagonals, yes? Write those out. It's your diagonals, guys. Write those out and try it. I have the 3.5 times x. And I have the 6 times 17.5. Try this. This is why I had everyone have a calculator at their desk, right?
Yeah.
Otherwise, I feel bad for saying try this. Because yes, it's not so nice decimals and all that. But, nope.
That's not it.
Nope. Try again. Did you do your cross products?
Well, that's going to be 35x.
Okay, and what about the other side?
And then you do 17
Where's your
times
work?
5, which is 35.
I'm not even 100% sure what that says, but it's a rocky scribble there. What are your cross products? Actually, write out what I just wrote out. I just did cross products here. No, up here on this one. I'm trying to get you guys to get this answer. No, I was trying to finish this problem here. I'm trying to get you guys to get this answer.
Okay, I got it.
Okay, there we go. We're making progress.
I didn't know you were talking about that.
I'm trying to make sure that you guys can at least solve this, set it up.
I think I got it. So
3.5 times x is
3.5x.
3.5x. I don't know, what's 6 times 17.5?
Is it 86? No.
No.
It's 30.
6 times 17.5.
But it's 6 times 7 point. So, I see what you're saying. 6.17.5. Which gives me the approximate 105.
Okay, there's 105. You guys please follow along with me. You're not listening to my questions. It's 3.5 times x. We're going to divide by that 3.5. And I know quite a few of you have this, but not everyone did. 105 divided by 3.5
30.
is 30. Now on this one, can you put a label on this one? 30 what?
30 feet.
Yeah, what was the question asking?
About the feet.
How tall is the flagpole? All the other dimensions they gave us were feet. So we're looking for 30 feet there. Okay. Guys, that whole idea of setting up these proportions is important. We're going to go down here and we're going to talk about a map, but we're still going to be doing the same idea, setting up these proportions. So help me out here, got it? When we talk about scale drawing, when you look at a map in your social studies book, okay, map in your social studies book, you'll usually see some kind of little scale, right?
Yeah.
Where it'll say, like, for example, 1 inch on this map is actually 110 miles in real life. Well, okay, how does that work? In other words, for instance, if we're using this scale here, and the map distance, so if I look at a map from Jacksonville to Orlando, it's 1.25 inches. What's the actual distance? What do I actually have to drive to get from Jacksonville to Orlando?
At least 110.
Okay, why do you say at least 110? That's a good way to start.
1 inch is 110 miles, and there's already an inch on it.
Okay, 1 inch is 110 miles. This right here is more than 1 inch, yes?
Yeah.
Okay. What have we been setting up all day yesterday and all day today? Proportion. So guess what I'm going to set up?
Proportion.
Proportion. In other words, I want Ryland's answer of at least 110 miles is good, but I want exact, right? Now, right here, guys, is one of your fractions, the scale they give you. What's the scale they give me?
1.25.
1 inch over 110 miles. Now, that's the scale they give me. Okay, Robbie, put them up. What else do they give me?
1.25.
1.25 what?
Inches.
Inches. If we're trying to be consistent, where do I put that 1.25 inches? If this first one is inches over miles, then I want to be consistent and I want to put inches over miles. They give me 1.25 inches. So where am I going to put that? On top. We're trying to find the actual distance. So if I'm driving, I'm trying to find that distance. So I'm going to put X on bottom. Okay, so use the fraction they give you and then set up your other piece. And guess how we solve here, guys? Yep, cross products. And when we do the cross products, don't worry about the inches and miles. Just multiply the numbers.
So let's go 1x.
So 1 times x is 1x. The other piece, $110 times 1.25. What is 1 times x? 1x, or in other words, just x. What is 110 times 1.25?
132.
Is he right?
Yeah.
Wait, what did you say?
137.5? $137.5 what?
Inches. I mean, miles.
Since it said find the actual distance, this is miles. Now, does that go with Ryland's observation earlier? More than 110?
Yeah.
It does, doesn't it? We were expecting more than 110. We got more than 110. That's about all we know, but hey, we got more than 110.
Yeah. Or you did the next one.
Okay, well,
You set it up and everything.
the next one, map distance from Jacksonville to Gainesville is 0.6 inches. Find the actual distance
Where's Gainesville?
in Florida.
Oh, it is.
Okay. Here's my help, guys.
You just have to.
There you go. That's my help.
You have to cross multiply everything.
That was a lot.
Yeah, that was.
I want you guys to know how to do something here.
We do. We just don't. Like,
Okay. What they gave us half of this, right?
Yeah.
What's the given I already know that I can set up?
0.6.
1 over 110.
Before we give it to the 0.6, were we given 1 to 110?
Yeah.
A scale of 1 to 110 means I'm going to put 1 over 110. Now that 1 represents inches. The 110 represents miles, so you want to be consistent. Inches over miles. What else did they give me?
Whatever's next. Which is 0.6.
They gave me 0.6. Do I put that on top or bottom?
Bottom.
Is it 0.6 miles? No. It's inches. Where do inches go?
I guess top.
On top. You got to be consistent. It's 0.6 inches, so we're going to put inches on top. And that means X goes on bottom.
Okay, so this is going to be root of 1x. That equals 110.6.
Okay. Cross products. 1 times X.
1x.
110 times 0.6.
Hold on. I got you. Why are you laughing, Robbie?
Let's do the math, guys.
I was breathing.
110 times 0.6.
I breathe like a horse.
110. Do I have to put the 0? No, I got it anyway. Wait.
66.
Yep, 66.
66 what?
Inches.
Miles.
Since it was on bottom, it's going to be miles.
Oh.
Okay. This bottom one is the same thing.
It's so easy.
If I give you 10 minutes, can you guys actually get in your homework and start working? In other words, if I stop the notes here,
Yeah. This way.
Yeah.
stop the notes. I'm gonna stop. I'm gonna go ahead. And if you want to check this one, did you get the right answer, Ryland?
Yes. I know. I didn't even do anything, to be honest.
Okay.
I just 60 times 50. It's that easy.
Now, I want you guys use this 10 minutes, get in Math Excel, and get a little bit of work done.
Got you.
No excuses. Get in there, logged in immediately.
To be honest, if I was doing my homework last semester, I probably would have done it.